Okay, so picture this. What if building a data warehouse didn't require you to know any complex SQL code? No memorizing syntax, no writing endless DDL statements. What if you could literally just describe exactly what you want in plain English, and then sit back and watch the underlying architecture build itself? I know, it sounds completely like science fiction, right? Like something that's still years away. But the crazy thing is, this massive paradigm shift in data engineering is actually happening right now in real production environments.
Welcome to this explainer. I am absolutely thrilled to guide you through this today. We are looking at a total ground-up transformation in how modern organizations manage their data pipelines. For years, we've just been stuck in this era of manual, code-heavy, and honestly incredibly brittle infrastructure. But we're officially entering the era of generative AI-powered reasoning agents. So today, we're going to break down exactly how these autonomous systems work, why they are drastically faster, and most importantly, how to deploy them safely.
So here is our roadmap for today. We'll be hitting 1. The SQL expertise barrier, 2. Intent-driven data engineering, 3. Automating data transformations, 4. Ensuring AI data quality, and finally, 5. Safe and governed architecture. Let's just dive right in. Starting off with Section 1, the SQL expertise barrier.
Think for a second about the daily life of a data engineer or an analyst. When a business user needs a new table or maybe a complex view to track a recent product launch, they usually have to submit a ticket and just wait. And why is that? Well, it's because there's a massive technical roadblock. An engineer literally has to sit down, manually write out the DDL syntax, figure out all the complex joins, define precise data types, set up constraints, and then, of course, troubleshoot the inevitable syntax errors when something eventually breaks. It's just a huge amount of friction. We're relying entirely on a very small, highly specialized group of senior engineers to translate business logic into technical implementation. And that just creates this endless queue of trial and error.
But here's where it gets exciting. By switching to automated data warehousing agents, organizations are seeing a 60% to 80% reduction in development time. I mean, really think about that for a second. Imagine taking a 5-hour task and getting it done in just 1 hour, well before lunch. That's time your engineers are getting back to focus on actual system architecture, security, and query optimization, rather than spending their whole day typing out repetitive boilerplate SQL. The machine handles the rote memorization of syntax, and the human finally gets to focus on the actual business logic.
And this shift is really all about moving away from static scripts and moving toward reasoning agents. Traditional static scripts, as we know, require manual triggers, manual validations, and honestly a lot of human babysitting. But an AI agent? It's context-aware. It doesn't just fill in a pre-written template. It actually reasons through the problem. It makes dynamic decisions based on your input, tests its own assumptions, and validates its own actions before it ever executes a single thing. So how does this actually work under the hood?
That brings us right into Section 2, Intent-Driven Data Engineering.
Let's look at how a system like Amazon Bedrock's text-to-SQL architecture takes a simple, natural language prompt and turns it into a fully validated query. It's basically a highly dynamic 5-step workflow. First up, the agent analyzes your question, smartly breaking down complex multi-part requests into independent subqueries. Second, it uses a retrieval system to actively pull in your company's specific business context. Third, it generates the structured SQL and strictly validates it for errors. Fourth, and this is super cool, for really complex queries, it ramps up parallel compute, running multiple agents at the exact same time to race and find the best reasoning path. And finally, step 5, it synthesizes the raw database results back into a really clear, natural language narrative. It's just a continuous, intelligent flow.
The real-world impact of these autonomous agents is absolutely jaw-dropping. To put it into perspective, creating 2 detailed data warehousing tables used to take about 30 minutes of tedious planning. Mapping out data types, writing the syntax, testing it. With an AI agent, just 3 minutes. Creating complex views with multiple layered joins and aggregations drops from 45 minutes down to less than 5 minutes. You literally just pass your intent to the system, something like, hey, join the employee and department tables where the department is IT and tenure is over 5 years, and the model just handles all the heavy lifting for you.
Now you might be wondering, wait, how does the AI actually know what my business means by a specific term like department or revenue? Generic AI models hallucinate all the time because they don't know your specific company.
Well, that translation gap is solved by Graph RAG. It combines vector search with graph traversal to link your company's specific business definitions directly to your underlying database schema. So it knows exactly what revenue means in your specific environment, which exact tables contain it, and exactly how those tables connect to each other. This is the secret sauce that makes the generated SQL actually accurate and immediately usable.
Moving on to Section 3, Automating Data Transformations.
The really cool thing is that this intent-driven approach isn't just for building raw tables from scratch. It's completely revolutionizing popular analytics engineering tools like dbt-2. You can now use large language models like ChatGPT or Claude as an incredibly powerful co-pilot in your daily workflow. You just prompt the LLM with your transformation goal in plain English, and it'll generate the necessary SQL, write the modular dbt models, and even auto-generate the configuration files, like YAML schemas, complete with full column descriptions.
The payoff for pairing dbt with LLMs is just massive. It drastically accelerates model creation, for one. It takes your messy, complicated legacy logic, the stuff nobody on your team actually wants to touch, and converts it into incredibly clean, optimized SQL. It also completely automates the tedious documentation process that, let's be honest, engineers usually hate doing. Ultimately, it reduces routine coding time by up to 60%. But keep the golden rule in mind here. The AI is a co-pilot, not a replacement. It frees you from the daily drudgery so you can step back and actually focus on high-level architecture.
All right, Section 4, Ensuring AI Data Quality.
Let's be real for a second. Here is the harsh reality of this entire paradigm shift. All of this incredible automated speed is completely useless if the underlying data the AI is using is flawed. Check out this stat. Gartner estimates that 80% of enterprise data is unstructured. We're talking loose PDFs, customer call transcripts, sprawling email threads, and 95% of that is completely unmonitored. That is a massive organizational blind spot. And trust me, you will feel the absolute pain of this the exact moment you try to launch a highly visible AI project, only to realize your entire foundation is built on messy, inaccurate data.
Historically, data teams would write manual quality rules to sanity check their tables. Something like, if this column is null, throw an error. But that approach only catches the specific issues you already know to look for. Reaching full coverage using manual rules across an enterprise data warehouse can literally cost 25 years of full-time human effort. Absolutely nobody has time for that. Instead, modern platforms like Anomalo, running natively on Snowflake, are shifting us directly to machine learning-powered quality. This approach automatically profiles both structured and unstructured data, detecting hidden anomalies, missing data drops, and even tone inconsistencies in text, all without constant human babysitting.
The real kicker here is this. Right out of the box, these ML automated checks can find almost 80% of all data quality issues without you having to write a single manual rule. It just continuously monitors data freshness and structural anomalies in the background. That way, when your new, super-fast AI agents go to pull data for a critical business report, they're pulling fresh data you can actually trust.
Which brings us to our final section. Section 5, Safe and Governed Architecture.
Okay, time to address the elephant in the room. I know exactly what you're thinking. This AI is incredibly fast, the automated quality sounds amazing, but what happens when it makes a critical mistake? How do I ensure a highly autonomous agent doesn't misinterpret some vague prompt and accidentally drop a critical production table? It's a completely valid fear. We've all heard the tech horror stories of a rogue script wreaking havoc.
You absolutely cannot just plug an LLM straight into your production database without serious guardrails. A true production-ready architecture requires strict governance. First, you create dedicated database users for the AI agents that strictly block all drop, delete, or truncate commands. The agent is there for scaffolding and design, not destruction. Second, you enforce row-level security so the agent only ever accesses authorized data. Third, for any highly critical operation, you implement human-in-the-loop workflows. That means the agent drafts the complex action, but a human still has to physically click approve.
But perhaps the most vital guardrail in this new era is the use of deterministic validators. You see, an AI might write a SQL query that has perfectly valid syntax, but is semantically highly dangerous, like an unbounded table scan that costs a fortune in compute, or maybe a query missing a critical security filter. Deterministic validators inspect the abstract syntax tree, the underlying structure of the code itself, before execution. If they catch a risky operation, they instantly block it and force the AI agent to revise its own query. This is a safety-critical layer that completely removes the operational risk from AI hallucinations. Which brings us to the final thought I want to leave you with today.
The technology to completely automate the repetitive boilerplate of data engineering while simultaneously ensuring high data quality and ironclad safety is already here. It's no longer just some fun futuristic concept. It's an executable architecture you can build today. So the question is, are you and your team going to stay bogged down writing manual syntax, or are you ready to embrace the shift and start designing your data infrastructure with intent? Thanks so much for joining me on this explainer, and I really hope this sparks some incredible ideas for your own data pipelines.